Okay, so today we're going to take a look at the volume of a pyramid. We have taken a look at the surface area, so now we're going to take a look at the volume. This should be a little bit easier than the surface area because it only requires two parts. So you'll see the formula here. The volume is equal to 1/3 times the base squared. So we're going to have to square the base times the height. So we're looking at this because these are going to be all square pyramids. We just need one base, either one, they're both the same thing, and the height to do this. So we'll do one straightforward, we'll do one with the Pythagorean theorem, we'll do one working backwards, and you should be good from there. So let's start with this one right here. So it says find the volume. If you look here, I have a base of 10, right? That value is 10. We have a height of 12. So I'm just going to plug those into the formula. I have volume equals 1/3. Again, my base is 10 here, so I'm going to put a 10 squared, and then my height is 12, so I'm going to multiply by 12. And then it's just a matter of following PEMDAS. I'm going to start with the exponents first. 10 squared is going to be 100, so I have volume equals 1/3 times 100 times 12. All right, and the next thing I'm going to do is multiply 100 by 12 because 1/3 doesn't go evenly into 100, so I'm going to multiply it this way first. So that's going to give me 1/3 times 1200. And the last step here is just to multiply these. And if you did, or you put them in a calculator, you should get 400. And then don't forget about the inches as our unit. And because we're finding volume, this is a measure of the third dimension, so it's going to be to the third power, right? So it's 400 inches cubed. That's a straightforward way how to find the area, or excuse me, the volume of a square pyramid. What I want to look into is how the Pythagorean theorem applies. So let's take a look at this example down here. Again, it says find the volume, but if you look, I have my base, which is 6, and they also give me the slant length here. If you can't see that, the slant is 5. So what I'm missing right now, I'm missing the height. I need this value here. So it requires us to do the Pythagorean theorem. We know that value is 5. We know from using the surface area that if I split this right down the middle, that this value is 3. So in order to find the height, we can do the Pythagorean theorem because that's a right angle going straight up. So I could do a 3 squared, h squared plus 5 equals 5 squared, Pythagorean theorem. Let me do that. 3 squared plus h squared is equal to 5 squared. Some of you guys would already know this is a Pythagorean triple, so you won't have to do this out, but I will. It'll be 9 plus h squared is equal to 25. Subtract the 9. I have h squared is equal to 16. Square root both sides. I have h is equal to 4. So now I know the height is going to be 4 by finding the Pythagorean theorem, or using it to find, using the Pythagorean theorem to find the height. So last thing I need to do is find the volume. And it's the same thing as we did with the previous problem. Volume equals 1/3. The height is going to be 4 squared, and then the base is going to be 6. So again, I'm going to do the 4 squared here, which is going to be volume equals 1/3 times 16. Oh, excuse me, I reversed these. This is supposed to be the 6 in here, and that's going to be the 4 here for the height. So this is actually going to be 36. I apologize about that. This base has to go inside the height here. This could be 36. And then we're going to multiply by 4. 1/3 goes evenly into 36. So if I multiply 1/3 times 36, that's going to give me 12. And then 12 times 4 is going to give me 48. And again, we're using inches. So it's going to be inches cubed. So sometimes the formula is straightforward. You could just kind of plug into the formula when they give you the height and base. Sometimes you need to use the Pythagorean theorem to find the height, and then you still have the base here to actually evaluate for the volume. In this last example, what we're going to look at is what happens when I give you two pieces and you have to go find the other. So this is what happens when you're finding a missing piece. So right now it says find the height of the pyramid given the base and the volume. Right here we know the volume is 32 and the base is 4. So if I write out the formula, I have volume equals 1/3 the base squared times the height. I'm missing that value there. But I can substitute in the values I do know. The volume's 32, so it's going to go here. The base is 4, so that can go in. I'm going to leave the height as h. So now you see that you're just solving for a missing variable, and you just got to simplify one step at a time. So what I'm actually going to do first is the exponent. So that's give me 32 is equal to 1/3 times 16 times h. And I think the best way to go about this is to avoid the fraction. So I'm going to start by getting rid of that coefficient and dividing by 16 on both sides, because I think you guys know that 32 divided by 16 is going to give you 2. And that's going to give us 1/3 h. And the reason why I did that is because it sets up for a nicer fraction. A lot of what you learned in Algebra 1, and probably something we emphasized a little bit this year, is that you can't divide by fractions. What you need to do is multiply by the reciprocal. But the reciprocal of 1/3 is just 3. What I do to one side, I have to do to the other. So when I multiply by 3 on both sides, those are going to cancel, leave me with h. And then 3 times 2 is going to give me 6. So now I have the height is 6 inches. I think the big deal here is you need to recognize that you're missing information. Specifically, you're missing the height. It tells you it in the question. And then when going after that, you have to find the best strategy to simplify this right here, right? What I did is I got rid of the whole number onto one side to keep me a whole number here. Because when I'm left with 1/3, I know I just need to multiply by 3. There's multiple avenues of solving this. So if you watch another video or see a different way that you learned in Algebra 1, feel free to utilize that. But that's volume of a pyramid.